Hello guys, I am Mangireddy Sandeep Kumar Reddy. I am studying third year BTech in Karunya University. I am explaining experiment 7 performing analysis of KNN classification technique. It is one algorithm in ML. First question. Develop a KNN classification model for diabetes dataset using the skip learning. First in first question, yes. Sub question number 1. Read the data. Data clean. Replace 0 in glucose, BP, skin thickness, BMI, column with NaN value. Identify the column with null value. Fill the null values by inputting the mean values in 4 columns. Third question. Use the columns glucose, BP, skin thicker, and BMI, and etc. Fourth question. Use the target variable as outcome, no, none, diabetic patients, and yes, diabetic patient. Encode the categorical value of the target column to numerical value. Sixth one, divide the data into training 75% and testing set 25%. Perform the classification with k is equal to 3. Analyze the performance of the classifier with various performance measures on display such as monument matrix, aggressive recall, weak and F square receiver operating characters, curve and area under curve score. Change the last question. Change the value of k in KNN with 5, 7, 9 and 11 and tabulate the various TP, TL, accuracy, F score and AUC score obtained. This is the code K values. K is equal to 3, K is equal to 5, K is equal to 7, K is equal to 9, K is equal to 11. These are the K values. TP, TN, accuracy, F square, AU square. Last question. Analysis and infer for which K value the specialized classification algorithm provide better performance. This is the question. This is the code. First, we have to import the pandas as PD, and next we have to import it numpy as NP. For SQL learner model selection, import train, test, split, and from SQL import simple importer. First question, read the data. Here df is equal to pd dot read csv file. But we taken as csv file as diabetes. Here print shape dot shape comma dot df comma df dot shape, print df dot column, print df dot head. Okay. Here second question, data cleaning. Column with 0 invalid is equal to glucose, BP, skin thickness, and BMI. We have to replace 0 with specified columns. Okay, df is equal to columns with 0 invalid is equal to df, column with 0 invalid dot replace 0 comma np dot na. Null counts is equal to df dot is null dot sum. Print, we are printing the column dot comma null count. Inputter is equal to simple inputter string is equal to mean. Df is equal to column with 0 invalid is equal to input. Okay, this is the and verify the column unknown. Column null counts after is equal to df dot is null dot sum. Third question, select features. Feature is equal to glucose, blood pressure, skin thickness, and BMI, diabetes prediction and age. X is equal to df features dot copy, y is equal to df outcome dot copy. Encode target if need, many CSV already we have 0, 1. Okay. If y dot d type is equal to object or y dot d type is equal to category, L is equal to label encoder, y is equal to LE dot print target classes mapped, comma DICD zip LE. If it is possible, it will print target class mapped. Otherwise, it will target D type. Scalar is equal to standard scalars and X scalar is equal to scalar fit transformation. X train, comma, X test, comma, Y train, comma, Y test is equal to train test split. X scaled, comma, Y test size is equal to 0.25. Random state is equal to 42. Print print test sizes is equal to, comma, X train shape, comma, X test shape. Matrix functions. Define compute matrix Y true, comma, Y print and Y print numbers. CM is equal to configuration matrix Y true, comma, Y print. TN, FP, FN, TF is equal to CM dot reliable. Occurrence is equal to occurrence score Y true, Y predict. Prediction is equal to score. Okay. Recalls is equal to recall score Y true, comma, Y print 0. If it is possible, it will show the Y true, comma, Y problem, except and it returns as TP is equal to input TP, TN int TN, FP is equal to int FP, occurrence is equal to occurrence, prediction, okay, recall as recall, and F1 is equal to F1, AUC perform classification with K3. We have to perform classification with K3. K3 values are 3, 5, 7, 9. Result and plot figure is equal to fixed size equal to 8, 6 for K in K value. K name is equal to K neighbor classification classifier. For R, OC, AUC, we need probability for the positive classes. If K predicts and Y matrix is equal to compound matrix Y test, comma, Y predict and Y probability. Y matrix is equal to K. Plot the formatting for ROC. Plot 0, 1, 0, 1, line is okay. Plot X line is equal to 0.0, 1, 0. Flip point is equal to 0.0, 1.5. X label N failed positive rate and Y label taken as true positive rate recalls, and title is ROC curves for different KNN, and legend is equal to low rate. Tablet result K, comma, here data frame result K, comma, TP, TN, accuracy, F1, AUC. Here is a print table summary is equal to T, and we give the values and everything. Also print the detailed matrix per K. Here is the code. For all this code, we have the same. We have the output shape 768, 11. Index name, city, glucose, blood pressure, and BPM. Okay, is the table. Null counts per column. Name is equal to 0, city is equal to 0. For all this replaced, which the values are replaced with 0. Okay. Here is the graph. We taken as true positive rate recalls and false positive rate. When K is equal to 3, AUC is equal to 0.772. When K is equal to 5, AUC is equal to 0.795. When K is equal to 7, AUC is equal to 0.793. When K is equal to 9, AUC is equal to 0.791. When k is equal to 11, a is equal to 0.791. It is for random. Here is random is this. This purple line is k is equal to 11, and k is equal to 9, it is red line. K is equal to 7, it is green line. K is equal to 5, we have orange line. K is equal to 3, we have blue line. Summary of the table in brief, it gives us, see, k is equal to 3, 102, 102, 23, 27, 403. That TP is equal to 40, TN is equal to 102, FP is equal to 23, and accuracy is equal to accuracy 0.7396. Specification is 0.8165. When k is equal to 5, 103, 22, 28, 38. Accuracy is 0.739 and the specificity is 0.8240. When k is equal to 7, 106, this is the matrix, and accuracy is 0.748. When k is equal to 9, is 108, the accuracy is 0.7344. When k is equal to 11, it is the accuracy and specificity. It is the sum. Higher accuracy alone can be mishandled for imbalanced access. Check recall certification and scientific and other together. If we care more about catching diabetes, minimum false negatives and recall. If we care about avoiding false positives, come up F1 balance plus and recalls. AUC closest to 1.0 means between discrimination across the threshold. Choose the K that gives and gives the code and output for 7. Thank you.